Okay, so for the first question, it asks why the natural logarithmic function y equals ln x is used much more frequently in calculus than the other logarithmic function y equals log b of x. And the reason why is because it's easy to differentiate y equals ln x than y equals log b of x. So, for example, this is just going to be 1 over x, while the derivative of y equals log b over x is a bit more complicated. It's going to be 1 over x ln x, or x ln 10 b. So that's why. Okay, moving on. Start with number 2. So we're just going to differentiate. Oh, and before we get started, I just want to point out that we're going to be using this rule right here basically for the entire homework. All right, so let's start off. So to start, I'm just going to use the general rule, and dy dx is going to be 1 over 3 plus x squared times d dx of x squared. So if I simplify again, it's just going to be 2x over 3 plus x squared. And that right there is our first answer. Moving on, y equals ln of x squared plus 3x plus 5. So I'm just going to use the same rule again. So derivative of x squared is 2x, plus 3x is 3, plus 5 is just 0. It's going to leave us with this answer. Moving on. So we're going to have to use a product rule here. So and then the product rule is going to leave us with ln x plus 1 ln x. Oh, the question. I wrote it wrong. Minus x. Here you go. Minus 1. And that's just going to give us ln x. So that right there is our answer. Okay, so we're going to have to use the chain rule for this one. Derivative of sine is cosine. The inner function stays the same, and then we take the derivative of ln x. And then the derivative of ln x is just 1 over x, and 1 over x times cosine ln x is just going to be this. That's our answer right there. Okay, moving on. So I want to note a rule that we're going to use for this one. We're going to use this rule. I think this is like the exponential power rule. So this is a rule that we're going to be using. And b for this equation is going to be 2. So first, we're just going to rearrange it. So 2 ln sine x. I haven't differentiated yet. I'll do that in the next step. So then this 2 is going to stay there times ln, so it's going to be 1 over sine times the derivative of sine, which is cosine. So it's going to give us 2 times cosine over sine x, and that's going to give us 2 cotangent x. Alright, so for this one, same thing. We could rewrite this, which is what I'm going to do. So I'm going to rewrite it like so, x to the negative 1, and the reason is that 1 over x is equivalent to x to the power of negative 1. And then we're going to use the rule that we used in the last problem, the same one. Y equals negative ln x. Then we're going to differentiate, which is going to give us negative 1 over x. Next one. Let's go ahead and do the same step that we did in the last problem. We're just going to rewrite it, ln x to the power of negative 1. And then we're going to differentiate, which is going to give us negative ln x, negative 2. And we're going to go ahead and use, or apply the chain rule. which is going to give us I'll go ahead and draw an arrow. And dy dx is going to equal -1 over x ln x squared. And that right there is our answer. So then for this problem, let's go ahead and start by differentiating 1 over x times e to the power of -2x times the derivative of that. Okay, so let's go ahead and continue a step. Times. So we're going to have to use a product rule here, and that's going to look like e to the -2x minus, because 2x e -2x. There we go. And the reason why is that the derivative of e to the -2x is just going to be -2e to the power of -2x. And then the product rule has it so that it looks like this. And then from here, we're just going to go ahead and simplify a bit. So it'll be e to the -2x minus 2x, and that will give us and from here we can go ahead and simplify or factor out an e to the -2x. To give us 1 minus 2x and x e -2x. And from here, these two terms will cancel, which gives us 1 minus 2x over x. So that right there is our answer. And we could have done this simpler. There's a second way to solve this. So I'll go ahead and do that right there, just because I wanted to show you. So then from here, we can go ahead and use our rule that we know. If there's two functions and it's yeah, okay, I'll just show you. So it would look like And we can go ahead and use the exponential ln rule. And ln e, they just cancel each other. So it would be and the derivative would be 1 over x, oh, it was 1 over x minus 2. And then these two answers, are equivalent. So that was another way you could have solved as well. Moving on. Okay, so for this one, I'm just going to go ahead and start by rewriting it. And let's go ahead and differentiate. And then we're going to multiply by the derivative of the inner function. So let's go ahead and simplify again. And that's going to give us one over x, and then we'll go ahead and simplify it one more step. Oh, whoops, it's not correct. Yeah, it's good. Okay, here we're gonna have to use a product rule. Yeah, product rule. So exponent rule, chain rule, product rule. Yikes. So derivative of ln x is just going to be 1 over x and times sine x plus so that right there is just a product rule. It's just the first step. And then I'm going to go ahead and simplify it. Yeah, and here I'm not going to simplify further. All right, so for this problem, I'm also going to go ahead and rewrite it. Then let's go ahead and differentiate. No, actually, not. So we're going to use a exponent rule. We're just bringing the exponent to the front. Then we're going to differentiate. And the derivative of x squared plus 1 is just 2x. So then it's going to cancel out. It's going to be these two 2's. Giving us x over x squared plus 1. All right, that's the first 12.